Okay. Just give me one.
What does KW stand for?
Kw is the ionization constant of water. So Kw is always going to have the same value, and Kw's value is always going to be 1.0 times 10 to the minus 14. So if you are using the formula where that has Kw in it, this, you always know this value. And then you either are going to be given this value or this value, and you can figure out the other thing. Does that make sense? Okay. Now, the term pH, you've probably heard it before, and if you have a pool at home, you're supposed to check the pH of your pool at home or hot tub or whatever, so that you don't burn your skin off, right? But pH translates from some French phrase that means power of hydrogen. And basically what it's getting you to try to see here is that every solution that is either acidic, neutral, or basic has a specific amount of hydrogen floating around in it. Yesterday we talked about the fact that if the H3O plus was equal to the OH minus concentration in a bucket of water, for example, you had a neutral solution. Yesterday we talked about the fact that if the H3O plus was bigger than the OH minus, you had what kind of a solution? We had an acid solution. Yesterday we said that if the OH minus was bigger than H3O plus, we had what kind of a solution? We had a basic solution. And so the thing is that the formula that allows us to calculate pH, that is the relationship to how much hydrogen is floating around in solution, is pH is equal to the negative log of H3O plus. And so if you know the H3O plus, you can very easily calculate a substance's pH. So we would take something like pH equals the negative log of H3O plus, and if we're using a neutral solution, like for example, water has an H3O plus of 1.0 times 10 to the minus 7, we learned that yesterday. If I take the value of the H3O plus and I plug it into the pH formula, I get a pH that is equal to 7, which is a neutral solution. Okay? And in a few minutes, I'm going to have you guys do the calculating so we can all make sure we can do this on the calculator. Okay? But there's a couple other things I want to show you. Now, we'll come back to this. The pH scale runs from 0 to 14. Ionization constant of water is 1.0 times 10 to the minus 14. That's no coincidence because it runs from 0 to 14. Now, anything that has a pH from 0 to just under 7, so like 6.9999999, is considered to be an acid. Anything that has a pH just above 7 all the way to a 14, okay, is going to be considered a base. Now if it's an acid, you have more hydrogen ions floating around than you do hydroxide ions. If it's a base, you have more hydroxide ions floating around than you do hydrogen ions. In a neutral solution, like a pH of 7, the number of hydronium ions and hydroxide ions floating around are equal to each other. So when we're looking at just deciding what the pH of a solution is, we're really deciding how much hydrogen is floating around. If you have a lot of hydrogen floating around, you have an acidic substance. If you have a very, very small amount of hydrogen floating around, you have a basic substance. And so here's another example that I'm going to have you calculate in a few minutes that says, find the pH of a solution that has a 0.25 molar hydrochloric acid. It's an acid, so we get to know what? What do we get to know if it's an acid? It's between 0 and 7, that's its pH. But in terms of calculating stuff, what do we get to know if it's an acid? We get to know the H3O plus. So this concentration of the acid is the H3O plus value in this formula. So I'm going to take pH is equal to, in this case, a negative log of 0.25, and that gives me a pH of 0.6, which is extremely acidic and actually quite dangerous. Now, this circly thing here. Okay? Note that what I have going on here is the relation is pH, POH, OH, and H3O plus. And there are distinct relationships between each of these boxes. Let's start with the relationship that we talked about yesterday. And the relationship that we talked about yesterday had to do with OH and H3O plus. What formula did we talk about yesterday that had both of those concentrations in it? The KW formula. So the KW formula allows me to calculate either H3O plus or OH minus, depending on what I've been given. Okay? So I can go back and forth from these two entities here using this formula here. Another formula that we just talked about today has pH and H3O plus in it. What's that formula look like? It's the negative log. So pH is equal to the negative log of H3O plus. So if I know this, I can eventually calculate this by using the two of these formulas. Okay? If I know this, I can easily calculate pH by just using one formula. Do you see that? So that's pretty much it. So you